In this video, we're going to learn how to tell whether an ionic compound is acidic, basic, or neutral. But before we can start with an ionic compound, we have to focus on the ions themselves. And remember, ions come in two varieties: positively charged ions that we call cations, and negatively charged ions that we call anions. And in this video, we'll just start to focus on anions first, and then cations second, and then we'll put them all together in a later video to see what can we tell about a compound as a whole. And so again, remember that an ionic compound is the whole shebang. So a compound contains both a cation and an anion. So it's impossible to find a bottle of, say, sodium or a bottle of, say, nitrite. Instead, you have to find bottles of things like sodium nitrite or iron 2 chloride. And so we're going to have to eventually learn how to deal with these compounds. But before we get there, let's go ahead and start with the individual ions by themselves. So first off, let's look at anions. And we're going to look at anions that come from weak monoprotic acids. And we'll see that they're actually basic. And why is that? Well, let's take a weak acid, HA. And what makes it weak is that when it reacts with water, there is an equilibrium. It's not a 100% conversion to products. And it forms the hydronium ion, which of course is acidic, and it forms this counter ion A-. And if we look at the HA, right, so that's the acid component of the story, and it's behaving like an acid because it can donate a proton. Over the other side, it's got a conjugate partner, right, a conjugate base, and it can act like a base because it can accept protons. So the acid can donate, the base can accept. That's the Bronsted-Lowry definition. So whenever we have a weak acid, we're going to have a basic conjugate base. So what are the common weak acids? Well, we've got things like hydrofluoric acid, we've got things like nitric acid, we've got things like acetic acid, and these are all going to be weak acids. And so whenever we've got the conjugate base of one of these, like F- or NO2- or acetate C2H3O2-, then these are going to be basic. So all these anions here are essentially going to be basic. So the question is, how do you recognize a weak acid? Well, the way you recognize a weak acid is that you say, hey, it's not a strong acid. So we're going to look at strong acids next, but normally I think backwards here, and I don't know very many weak acids, but I do know the list of 6 strong acids, and if it's not on that list, ergo, it must be weak. Now, if the anion comes from a strong monoprotic acid, that's actually going to be neutral. And the question is, why is that? So here's our acid HA, and it's behaving like an acid because it's capable of donating a proton to water. So this is the Ka reaction. And what makes it strong is that it's not actually in equilibrium. There's a 100% conversion into products here. So here's the hydronium, and here's the counter ion. So earlier, right, we identified this as the conjugate acid-base pair. So this is the acid, and this is the base. Now, the thing is, if it were acting like a base, it could accept a proton from the hydronium ion. But because it's a strong acid, it actually goes forward, and it does not go backwards. So that accepting of a proton does not take place. We can cross that out. So if it can't accept a proton, it's not really a base at all, is it? It instead is going to be a neutral compound. So whenever we've got a strong acid, so our strong acid lists are things like hydrochloric, and nitric, and hydrobromic, and hydroiodic, and perchloric. So I'll just pick 3 of those 5 strong monoprotic acids. It's going to have a conjugate base that is going to be essentially neutral. So chloride, nitrate, so I'm just removing a proton, perchlorate, and what were the other ones? Hydrobromic acid, so that would be bromide, hydroiodic acid, so that would be iodide. So all 5 of these anions here are not going to be basic like we would expect. They're going to be completely neutral. So I would recommend that you just memorize the neutral list. In fact, I would just remember that as long as you know your 5 strong monoprotic acids, the conjugate bases are all actually going to be neutral. And then when you see an anion, all you've got to do is compare it to this list. And if it's on this list, you know it's neutral. Otherwise, it's going to be basic. So for instance, if you had something like F-, you could say, well, F-, it's not on that list, so it's got to be basic. If you've got something like NO2-, it's not on that list. It doesn't come from a strong acid, so it's got to be basic. If it is something like NO3-, you can say, oh, it's on that list, right? It comes from that nitric acid, that very strong acid, so it's going to be completely neutral. And of course, a way to remember that anions are typically basic is that the hydroxide ion, of course, is what makes a solution basic. So whenever you've got a negative ion, right, you should start thinking, oh, hydroxide's that basic ion. So negative ions are generally basic unless they come from one of these strong monoprotic acids. So if it's from one of these, then it's going to be neutral.